Um, so a very, very good evening to all our friends who've joined us here for a really, really exciting session today. I mean, this is something that I've been looking forward to for a long time, and finally we've got the man himself, Stavros Danos, with us here, who's going to guide us through this session. Um, just give you a quick little before we start and get the session going. Just a few points on housekeeping points. I request everybody who's here to kindly mute your microphones. Only Stavros's mic and video will be on. Everybody mute your video and your audio. It's nothing personal against you guys. I'm sure all of you are great looking guys. It's just that we want to preserve the bandwidth so that we don't get into any bandwidth issues and then the session gets interrupted. So here we go. Let me give you a little brief on Stavros. Stavros was born and raised in Limassol, which is in Cyprus. And he was a guy who was from very early age interested in electronics and design. And he's basically a self-taught guy. But he did go to university and he specialized and studied in aeronautical and mechanical engineering, and with a specialization in mechatronic systems, mechatronic system design and robotics. So, I mean, he's the guy who'd probably be able to build the next Android for Tesla. He's but audio was his first love and his first calling, and mechatronics and robotics loss was our gain, and he dove headlong into this wonderful field that we all love, called audio. And he started a company called Aries Serat back in 2010. And his whole point of starting that company was reinventing audio. I mean, I know a lot of us talk about reinventing audio, but he's actually done it. And that's why we all bow down to you, Stavros. Um, he still continues to live in Limassol with his wife and his two sons, enjoying life. It's a wonderful place, I believe. So, any of you guys go down to Cyprus, please do go and visit him in Limassol. And he loves life out there, designing and building music machines, like he calls them. So, the topic for today's discussion is system synergy. Now, we all know that an audio system comprises of a source, a pre, a power, and speakers. Many of us forget the room, but there's a room. There's also the cables and the interconnects, which a lot of people focus majorly on, thinking that that's what's going to solve all their problems. Well, in the old days, I don't know if you remember, Stavros. I mean, in your youth, when you probably had a music system and all, it was always about getting the right impedance of the speakers to match with the amp. The speakers should match with this amplifier. This preamp should match with the amplifier or something. So does that really hold true anymore? I mean, with advances in electronics and advances in systems designs and all, is that still a topic that people really discuss and sit around and change system components just because they're not matching as such?
It's quite a limited way to see things. System synergies goes beyond just interface between amplifier and a speaker. In my opinion, system synergies begins at the owner, at the users. So if you start to build a system, you have to wonder, who are you building it for? Who's the guy who's going to use it, and for what purpose? What's his room like, and what his maximum, let's say, ceiling of performance in that room? I'm not discussing about budget, which is a huge limiting factor, but even a limited budget, if you have a small room, then your performance ceiling is going to be quite low. So the synergy goes way in a more holistic way than the average problems like, is this amplifier going to drive that speaker, which is also a big problem. But it's a very limited way to see issues if you're just going to focus on the speaker and electronic synergy. So going back to, let's say, from the end user, you have to understand what he's after, what his experience is, what is music he likes to listen. Maybe he's a movie guy, maybe he's into classical, or maybe he's into electronic dance music. You have to have a very good idea who are you addressing your system to be designed for, right? And the next stage is the room, what's the final position of the system. And because the worst thing to do is having a disproportional speaker to the room. You don't want to have a very small speaker in a huge, hall, and the other way around, a big, complicated speaker in a very, very minimal.
But wouldn't that sound counterintuitive? You can have as big a speaker as you want in a tiny room. You just play it at a low volume. I mean, that's what normally people would do, right?
The issue at hand is that some speakers can do that. Some speakers, they will, let's say, cheat their size. They are big speakers, but they can play in small rooms. But you can actually cheat physics. Sometimes it's going to be overwhelming, especially if you want to have some headroom and play some material with dynamics. Then you're going to overload the room quite easy, on let's say especially with big crest ratios, in music, when you want to listen loud, but you want to enjoy, have some dynamics. The room is not going to allow that. So but what you can do, the room is what is setting the first limit in performance, followed by the speaker. So first you have to decide which is the best speaker for loading the room, budget, of course, allowing. And then you start to, let's say, go to the more, known issues like, okay, I have this speaker, what do I drive it with? Which is also a much complicated matter than people realize. It's not just impedance. My speaker drops 3 ohms, can this tube amp drive it? Sometimes it doesn't go like that, because let's say you have a horn speaker, which is 110 dB, it dips to 3 ohms. It's going to behave way, way differently with a tube amp than a 85 dB speaker, which is 8 ohm minimum. So impedance can tell a lot of stories, but with modern amplifiers, they don't really care about, impedance variations. Of course, some amplifiers will, let's say, not like some ratios, impedance variations, especially phase capacitive loading with the combinations with very low impedance can really take an amplifier into a very, very bad region for its health, especially, big transistor amplifiers, which really dislike this kind of, let's say, combination.
This kind of loads, yeah.
Exactly. So let's say you have a speaker. Okay, what can I drive it with? You have to go and see beyond just the impedance. The impedance is a prerequisite for your amplifier. But you really need to match your amplifier in terms of not just synergy, in a way that you're gonna try to match your speakers, let's say, misbehavior with fixing it with an amplifier. You're going to fix a dull speaker with a very bright amplifier. That's a very wrong way to do it, which unfortunately it is a known way for users to, let's say, fix a system. In my opinion, you have to get system, component right from the get-go, not trying to fix it,
Yeah,
with another.
many people like to use equalizers in their systems to, like, tweak and tune and say, fix. There's not enough highs coming. Let's boost the HF. Let's boost it. Let's boost.
Equalizer is, you can fix everything with an equalizer. Let's say you have a very, very sensitive speaker, which on normal, environment, you're going to use just a few milliwatts of power, on quiet passages. If you have a very high power amplifier, usually push-pull or transistor amplifier, which they all have crossover distortion regardless of if they have feedback or not, you're going to have some very nasty artifacts down to the milliwatt level, which in a very sensitive speaker is going to be quite audible. So it's going to be a very big mismatch, doing very, very high sensitivity speaker, very, very transparent horn speaker, or even direct rallying driver. with an amplifier which doesn't behave well at milliwatt level. And the opposite is true. You know, if you have a very, very filter heavy speaker, which is very insensitive, very, very heavy drivers, you're not going to wake it up with let's say a flea powered, you know, run of the mill tube amp, or, you know, a very high impedance amplifier. It's going to be a very bad match there. So it doesn't stop to the impedance or the power. You always have to remember what your speaker can and will behave with your amplifier, not at the average level. You know how it's going to behave for a sensitive speaker to the very, very low level, and at the insensitive speaker at the very, very end of the other end of the dynamic spectrum
range.
So going back to the electronics, nowadays most electronics can drive. They have usually low impedance, output impedance. So on the old days, most preamps had some issues driving, you know, very low impedance amplifiers. It's good that we see more rare cases of very high impedance preamps, at least for the preamp. Sources are still, many of them have very high impedance, which regardless if you keep the, let's say, the rule of thumb 1 to 10, which is very low in my opinion, it has to be way, way bigger ratio than that one. You have to take into consideration what is driving what. So let's say you have a preamp which is very, very low impedance, which has its own benefits to be low impedance. Does your DAC can drive that load? You know, many tube DACs have very, very high output impedances. Many DACs that have attenuation on its output will have very, very let's say bad combination with the low impedance preamp. Most of the preamps, however, are very high impedance. So it's not, let's say it's more rare to see mismatching between source and a preamp than is to see with a preamp to an amplifier. But I always like to see a holistic view of getting from the cartridge or from the server to your room. You have to see what is driving what, and see everything in a holistic way, instead of trying to fix everything, you know, in retrospect, and usually it goes expensive.
As impedance matching is a very important aspect in all points of your design, and you can see it running through the entire range of your products, right, from your DACs, pre's, amps, and your speakers. Speaking about even your speakers, they are horn loaded because they're the best impedance match to free air, right? So I think you've cracked that there.
Impedance matching is a bit more complex, especially when you're designing equipment between stages. Also, you have to do, let's say it's not very straightforward, you know, impedance matching. You know, in paper, you keep the rule of thumb, you know, that the 100-year-old 1 to 10. It's not really the case, especially when you use let's say between stages. You know, the dynamic behavior of a stage, it's not the same as a sine you know, wave behavior or steady state. So you always fell short when you are conservative in trying to match impedances, let's say between stages of the driver to the output stage, you know, from the let's say the converter banks to its output stage on the DAC. So you really have to expand the areas that the impedance matching, let's say, goes. Even in an amplifier, a classic amplifier, or how the driver will drive the output and how the input will drive the driver. It really, from experience, a lot of designs fell short because they underestimate, especially this ratio. You always want to have some big headroom between stages. And this is what we take into consideration. We do a lot of A/B testing, and there is a lot, let's say, a lot to be desired when you design with the known, with the old rules of impedance matching. You always want to have some good headroom around that one.
So does this apply even to, so we spoke about between stages, like between your DAC, your pre and your amplifier. Now, when we talk about the amplifier and the speaker, the link between that is always a crossover. And a crossover is a very important component of any speaker system. In fact, I mean, you've designed a brilliant crossover system in the Contendo as well as also in the Aurora, wherein you offer the client a Bluetooth app wherein he can actually set the crossover points, am I right? And set the curves. But why would you do that? Aren't crossovers specific to drivers that you're using, and you're going to give that power to the customer? I mean,
that's a different. It's a good pass, let's say, to go there. But before going that, I'll give you an example, right? In terms of impedances, let's say you want to attenuate a signal. The best, the easiest way to do that is with a resistor attenuator. Either it's a ladder or R2R, doesn't matter. It's still a resistor attenuator. The output impedance of that attenuator, it is magnitudes higher than the usual output impedance of a stage. So it kills, even though in steady state it's going to measure okay, it's not going to look anything funny on distortion like. It is really killing the life out of music. There are ways to measure, how it changes by dynamic behavior, which is not easy to, let's say, for a user to understand how it does that. But let's say if you compare that to a TVC, a transformer volume control, which let's say the more attenuation you use, the lower the output impedances. So for example, a transformer volume control can have 1,000 times less output impedance, 1,000. I'm talking about 2-3 magnitudes lower than a normal, a resistor ladder attenuator. That is extremely detrimental in the performance and the clarity and the subjective and objective performance of a stage. You can expand that to, let's say, a crossover. Let's say you want to attenuate a driver, a compression driver, right? The usual way to do that is with an L-pad. It's a resistor
L-pad, correct.
Which has the same problems like a
ladder network.
Yeah, exactly. What we do is we use transformers to step down the signal, which is also on the output of that attenuator, the impedance is lower than the input, whereas in an L-pad is the opposite. The output impedance is much higher than its input. So the driver does not really like seeing higher impedances than the amplifier can provide. And it's not just a matter of, if you measure it, you're not going to lose much in terms of distortion, but the subjective performance of that driver is going to be night and day. Of course, it's not easy to develop these attenuators from scratch, especially custom for our custom systems, but it's definitely worth the extra mile or two to give you this benefit, which is very audible. But if you want to have, let's say, spec sheet, let's say, marketing about it doesn't say much, but the ear tells a very different story. So impedance matching, yeah, it goes a long way. It's not just your average, when my amplifier is 20K, how can I drive that? It goes from your output of the converter bank of the chip to the actual driver. So it's the whole philosophy of each stage to be driven. Another example is, let's say you have a set, classic set amplifier. You can drive the output stage with the usual small signal tubes that are overused, if you ask me, over the industry. You're still going to have, same power, but if you compare the drive with a big tube driving a big tube, it is different, not just a different story altogether. It's like a different game. It's very different to drive, an 845 with another 845 than to drive it with, a mini school, 12XX something tube. It's very
1287.
Yes, whatever that family is way overused. It's a family of 4 or 5 tubes. So again, it's not easy to do, but when you want to design something and not just not a Me Too design, it is a very very good way to go. Trying to push the boundaries and see what is the limit.